Okay, this is the right lesson we need to have. Basically, we learn the sample strategy. Why do we need to have a sample? It's very important for us to understand. Basically, it's very simple. When we say that we are conducting a research, we collect sample. Most of the time, we collect data from sample, but not the whole population. Okay, so all the data we have is from sample, not from the population. There is a difference between these two, and later I will explain that to you. So we will learn the concept of sampling terminology. At first, we need to know what they are, and factors affecting the inferences drawn from a sample, and the aims in selecting the sample, and types of sampling, and calculation of sample size. This is just for fun for you because we are not a math major, right? Okay. This one is very simple and straightforward, but very intuitive. Look at this one. We start with a study population. We want to identify. We want to start, for example, the purpose of my study is to investigate when our students are attitude toward environmental protection, right? So the study issue is attitude toward environmental protection, and the study population is Windsor students. So basically, this is the study population I'm talking about. And inside the population, there are a lot of sampling units. Look here, the tiny ones. They are sampling units. The unit I can take out put into the sample. We call sampling units. 抽样 Okay, 抽样的样本 unit. Okay, and Windsor has 9,000 students. It will be almost impossible for us to do a survey and dispatch questions to 9,000 students. So basically, I need to select a sample. So look here. In reality, in practice, I'll only select a small size of the sample for me to collect data. So imagine this. There are 9,000 students here. But actually, I could select around 5 to 1,000, most likely. Okay, not all. So you can see the 1,000 size of the sample does not equate 9,000 of the population, but it can represent. And the sampling strategy, carry out a very good idea. That is, since we collect data only from the smaller sample size, so our goal is to make sure that the characteristics of the sample is as close as possible to the characteristic of the population, right? If we have 9,000 students out there, and with our wonderful magical sampling strategy, we have 500 students. They are completely equal to the characteristic of the population. Wow, thanks God, right? And we have everything we need. We just survey them, we can reflect to the population. But normally we don't. But close. How can we assure that it is as close as possible? Basically, we select a few sampling units from the study population. There are two ways of selection. One is the random selection. Random. That is just run by the computer or whatever. There are many different kinds of random sampling strategy. But if it is random, then the characteristic of the sample and the characteristic of the population should be very similar. Is that right? And there's another way, non-random sampling strategy. Non-random, why do we need to use non-random if we can use random? Ideally, of course, random should be better than non-random approach, right? But in reality, in our social studies, most of the time we use non-random sampling strategy. That is, we select a small size of sample from the population, not based on random strategy. We just take whatever we have. right? We just take whatever we have and put into the sample and say, okay, we collect data and trying to do more analysis on it. Two ways, random and non-random approaches. Okay, two ways. What is the definition of random selection? Basically, you want to say something?
I think random sampling method is like, for example, you get someone to stand at a certain location, and whoever passes by, you just pass that question.
This is called as accidental sampling, not random. You will be amazed to find out it's very odd. The way you describe, just oftentimes you will see someone stands in front of some stores, right? You pass by and, hey, 小姐, please do a survey for me, right? So when they claim that this way is a random sampling approach, it is not. It is called as accidental sampling. Accidental refers to it just happened you are there. Just happen you are there. By accident, oh, 预抽样, that is different, okay? But anyway, let me explain to you. The definition for a random sampling strategy is that every sampling unit in the population has equal chance of being selected. That's it. So look at here. Am I a McDonald's consumer? Yes, to some extent, yes, right. But do I have the equal chance of being selected when the one dispatched one questionnaire to the pedestrian just passing by the McDonald's store? No, right? I do not have the chance to get selected by this surveyor. So basically, when we say the quality to judge, the criteria for us to judge whether the sampling strategy is random, we only look at that. Whether every sampling unit here, right, sampling unit has equal chance of being selected by the strategy. Equal chance of being selected is a very important criteria. Okay, all else are non-random. If you devise a way to select a sample that have a very absolutely provide each of the sampling units equal chance to be selected, then you are using sampling strategy, a random sampling strategy. If it is not, you are not. Okay? There are many different ways of the so-called non-random sampling strategy. The one accidental, or you select by judgment. Or I believe that you are qualified, so I give it to you. Okay? Or the snowball, just as you, right? Or the blind shot, you just put on the website and suddenly you have a lot back. And you claim you target the students, but sometimes the faculty member disguise themselves as a student and return that to you. So it's kind of shotgun approach. You just take it back. Oh, I have, right? Okay, so there are many different ways of sampling strategy. But now look here. We collect data, we select few sampling units from the study population and put into the sample, right? So basically, look here, it's very interesting. We collect information from this only. We only collect data from here. We have no access to collect data from the population because they are not in the sample for us to collect data. Is that right? When I try to investigate the attitudes of Windsor students, and I have only 500 students, suppose that I have only 500 students in my sample. So basically all my efforts are on the 500 sampling units, but instead of 9,000, is that right? Okay, so basically I collect information from these people and try to find out the answers to your research questions. How? I collect data only from 500 people, 500 students. But my research purpose is to understand, is to investigate 9,000 students' attitude, right? How can I do this? There are 500 students' data. I use, I collect, I analyze, and with this, I want to identify, try to provide answers for you, the answer for the 9,000 students. So basically, what I'm doing is, from sampling findings, I estimate. Did you see the keywords here? I estimate of their prevalence in the study population. So basically, I collect data from the sample. And with the sample findings, I estimate what happened to the population. See this? Very simple, right? So, if you want to make sure that your estimation is as close as possible, as precise as possible, then the characteristic of the population should be as close as possible to the characteristic of the sample, right? If they are equal, then your estimation is perfect sound. If they are not equal, then your estimation can be very misleading. Is that right? So this is the concept of sampling. Very simple. So far, are you good with me? Okay. I'll give you 2 minutes to go through the process by yourself. Okay, so the process is very easy. We collect data from sample. We use the findings from the sample to estimate the parameters of the population. That's it. All research are in this way. Okay, so normally we do not just collect data from the population. It's impossible. It's impossible, right? Okay. So let's talk about normal distribution. And remember one thing. We collect sample, right? We select a sample. We select a sample. So each time we select a sample, suppose we have selected 1,000 times of the sample. And let's see this one. And let's use a very simple idea for you to understand. For example, the average height of the 1,000 students actually, if we have the luck, if we have the access to evaluate, to collect the highest information for every student in Wenzhou, let's say is 160. 160, right? Then we select a sample. So sample 1, the average height shows that is 158. And we use the 158 to estimate 160, right? But of course, there's estimation. So whenever we estimate, we will say that the average height of the population would be something like this. If we know the number, something like this is standard deviation. Within 95% of confidence level. That is 95% of possibility. We have the average height from the sample is 158. Then in 95% of probability, the average height of the population will be between 158 plus and minus 3, which means that the average height of the population is somewhere between here, and the probability of this happening is 95%. Okay, normally. And look here, the first time we have 158, right? And the next time we draw a sample is 158.5. Still, we will try to indicate. So it is 150.5 plus and minus 3. It is never to be exact number of the 160. It's very rare happening. It is always, when we estimate, we provide a range. We provide a range. So, okay, the average we have collected is 158. So the population, the average height for the whole population is somewhere in between 155 to 161, and the probability of the happening is 95%. So under the 95% of confidence level, the population average height will be within the range 155 to 161. Okay, so that's how we call estimation. Is that right? We cannot say, okay, the sample is 158, then the population is 158. We never claim that. It's impossible. It's impossible, right? So we provide an estimation with a range out there. So every time you select a sample, you will find out one very intriguing scenario. That is, this 160 is the, let's say one more time. Let's say, basically, the real average of the population is 160, right? But imagine this. When you select the sample, the first sample, you find out the sample average is 158. Okay, so this is 158. Let me write it down. 158, 159, 157, and 161, 162, 163, and 156. Okay. Now let me show the magic to you. The first selection of the sample average is 158. So you have 1 point here. Is that right? Okay. And suppose you continue to select 1,000 times. And the second time, the second average, will that be just 158? Not really, right? Maybe somewhere here. Do you agree? And third selection, maybe here. The fourth, maybe here. And you can continue to select a lot of sample with the average distribution, right? So you'll find out that they will close to 160, but not exactly 160. Only in a very few rare occasions you will just 160, but you're somewhere in between. So you can see that you will just something close 1,000 times. 1,000 times. So you can see eventually it will be something like this. There is a central tendency, right? Okay? Central tendency. So eventually to unlimited time, you will be able to identify a normal distribution of the selection of the sample average. That is, it will something look like this. Okay? So the cross here refers to one average, the average of one sample. Okay? So you can see that there were a lot of selection out there. Eventually, the distribution will like this, will just like this, eventually. Okay? So this is called as normal distribution. The concept of normal distribution is very important for us to conduct effective statistical analysis. Because of it, all the statistical analysis is made possible. If there is no such thing exist in the whole wide world, then there is no way for us to infer, to estimate the results of the sample to the parameters of the population. It's impossible. So because of this, so normal distribution is very important. So let's move down to the next slide. Then you will understand how to connect these two together. Normal distribution. So did you see this one? This is normal distribution, right? And this is the average over here. Normal distribution. And this is the average over here. So let's take a look here. This is zero difference in terms of standard deviation. Okay, you don't have to understand. You don't have to know standard deviation, the definition of standard deviation so far. But it's sufficient for you to know there are no difference at all. Okay, no distance between standard deviation. Okay, and this is -1 standard deviation, +1 standard, and then -2, 2, 3, 3, and -4 and 4. Okay, and you find out that normal distribution has some certain characteristics, which is very important for us to understand. Let's see. -2 and +2. Within the negative and +2 standard deviations, around 95% of the sample mean will be located within this domain. Around possibly 95%, which means that if we have select 1,000 times of the sample, the means of those 1,000 samples, 950 of them should be within the 2 standard deviation range, negative and positive standard deviation. That's why a lot of time you will see a report from a survey, right? For example, the satisfaction, how satisfied you are toward the President Trump. So basically, the American surveyors, when they conduct the poll, they will survey around 1,200 people. 1,200 people, around that number. And the average satisfaction level for them, let's say, is 53%. This is from the sample, right? But they want to estimate how about the population. They would always say that, within 95% of confidence level, 95% of confidence level, the satisfaction of the population will be somewhere between 53% plus -3%. They're always expressing in this way. Is that right? Okay. So far, are you good? And let's take a 10-minute break and come back again. Take a look about this one. So normal distribution is very important, right? So when we do a poll, generally we will select 1,200 people as our respondents for our surveys. Is that right? And we use the average from the sample to predict the parameters of the population. That's what we do. And how good is the normal distribution for us? How can we use it? How can we use it? We know that 95% of the distribution will be within two standard deviations, right? Okay, let me give you one example. Maybe you could have some idea about the use of the normal distribution. Let's assume, do you know Mark Lai? Yes, you know, right? Okay, Mark was a good student in college when he studied in National Taiwan University. Let's assume this. We know his score, his final score, academic scores from that program is 75. Let's say that's a 75, okay, 75. That is his score. And we were lucky enough to know the standard deviation of his class, the same class. Okay, the same class is 3. Standard deviation is 3. And this is Mark's score, okay? and standard deviation is 3. And we also lucky enough to know the average score of that class is 72, okay? What is the ranking? What is the percentile of Mark's performance compared to his class? Let's say this one. We can have this idea. Let's say this is 72, right? Okay? And one standard deviation is 3. So here is 75. So Mark position is here. And how many people he wins? He won at that time 84% of people. Let's say this one. Over here. He is here. Is that right? So if you look at the cumulative percentage, he is the top 20 students in the class. And here is 72. We have a standard deviation of 3, and here is 75. Okay? Next time I'll give you a score in this way. If I give you a score in this way, to say, okay, congratulations, student A, you got 80. You got 80. You got 80. And the average score of the whole class is 60. And the standard deviation is 10. The standard deviation is 10. And the average of the class is 60. And your score is 80. So what is your percentile compared to other students? Anyone? Good idea? Here is the average, right? And we have 60. This is 60. And 10 standard deviation is 70 and 80, right? So you are here. Is that right? So really, congratulations, you are 97.7% of higher than other students. You are almost number 1, I think. So this is another way to know your position. That would be much precise for you. Just give you an 80, right? Okay. So let's see another way. If you get 80, you still get 80. You still get 80 points for the test. But if I told you that the average score of the class is 85, right? And the standard deviation is 2. What is your position compared to all of this? Anyone have a good idea? This will be one of the tests for the next quiz, so you need to know. So what is your location? If you get 80, and we know the average score of the class is 85, and the standard deviation is 2, then what is your position compared to all other students?
Is it 2.3 or 15.9?
Let's see this one, 2, right? We have 80 points here, 85 here. And the standard deviation is 2. So you can move on. Here is 83, here is 81, right? 2. And this is 79. And you are 80, you are somewhere here. Right? So actually you have a 2.5 standard deviation from the mean. Here is 2.5. So if you look at the cumulative percentage, you are around a very meager 1.5%. So which means in the very simple translation, you are the last one of all other students compared to other students. Even you get 80. Okay, so this is how we do the statistical analysis. And give us a very good idea. The idea of standard deviation is talking about the dispersion, the range we might have. A smaller standard deviation means the distribution of the numbers are close, are more centralized. If the standard deviation is large, which means that the dispersion is large, okay? For example, here, we say the standard deviation is 2, right? So you can imagine this. The distribution 87, 89, You can see 81 to 89, 95% of the scores are within 81 to 89. Very close, right? But if we say the standard deviation is 20, then that will be very, very diverse, dispersed in very huge range, right? Okay, so that is a very simple idea. Standard deviation can help you to understand how wide is the distribution. If the standard deviation is 1, it is certainly narrower, much narrower than the standard deviation for 20. Because 20 will disperse much wider, right? And standard 1 is narrower, okay? So basically, standard deviation, variance, or z-score, or t-test, they are all the numbers help you to understand the distribution of the numbers. That's it. But so far, it is good for you to know the idea of average number, the mean, and your score, and also the standard deviation. And also compare to identify the position of your score. This will be one of the tests for next time, okay? Okay, next. We know in quantitative research we do a lot of sampling, but how about in qualitative research? Normally we don't care too much about the sampling because qualitative research never aims to generalize its finding, right? So it's okay. So sampling research has less significance in qualitative research. Less. When we say less, sometimes we care, but most of the time we don't, okay? And there's a very important idea we call saturation point. Saturation point, 饱和点, which means if you add salt into the water, then with saturation point, you cannot add more salt into the water to be solved, right? So that point is called saturation point. In research, in the study, we have the similar idea. We have very similar idea, which means that we collect more data, but we do not obtain any new data, or the new information is negligible. Does not create any significant addition into your collection, then we have reached the saturation point. For example, 9,000 students, right? So what would be the saturation point that you could have, you determine to have? Well, it depends on you. It's a subjective judgment decided by the researcher only. However, your decision has to be based on literature review. For example, 9,000 students. You can decide to select 500, but you have to provide very good reasons why you select only 500 instead of 1,200. Or why you select 100 instead of 500 instead of 1,000. You have to explain. So you have to provide your reasons with a good evidences from literature. Okay? Saturation point is something you have to determine by yourself. Of course, there is some very simple rule for you to make a decision. Later, if you learn statistical analysis, you will have the idea. And also, when we do interview, if you claim you are conducting an interview, right? Often I have been asked by students, how many interviewees I need to have? Good question, right? Normally for undergraduate research, I would advise, let's say 10 to 15, because it will take you time. You have one summer to do this job, right? To do data collection. 10 to 15 significant, sufficient, sophisticated interview that will be good enough. But how about a method thesis? Well, I would say that depends on what you want to do. Maybe 20, maybe 30, it's up to you. Okay? So it is very difficult to determine how many, but there is some simple rule to say which is not good. For example, if this is your graduation paper, right? And you only interview 2. And each of the interview lasts only for 5 minutes. That would be very strange, right? Okay, instantly I will say, no, you are not qualified. Another case, You interview 20, but each interview lasts only 2 minutes. That would be also strange, right? So there were some criteria out there. But basically, you have to explain why you choose in this way. You can determine how many data, how much data you want to collect, but you have to express your reasons. Because the saturation point is determined by you only, right? Of course, your advisor can reject your claim. And on the ground that you do not provide good reasons for the selection. Okay? There are some sampling terminology here. We have a population or study population. We use the N, the big N, capitalized N, to represent population. We have a sample, we have a sample size. Sample size means the size of the sample. Okay, the size, but the sample is the target we collect data. Sample size refers to the number of the sampling units inside the sample. We have a sampling design or a sampling strategy. We have a population and then we have a sample, right? We have to select the sample. What is the method we use to select the sample units from the population? Is the so-called sampling design or sampling strategy. Sampling unit or sampling element, they are the same. The tiny man over there, the population, right, they are sampling units. And the sampling frame. What is sampling frame? That is the parameters. For example, 1,000 students, 9,000 students over there, right? We need to have a sampling frame so that we can select sampling units from the population and get into the sample. So we need to have a solid, obvious, evident name list for the students of 1,000, right? So this is sampling frame. We have to identify it clearly so that we can collect data from the sampling frame and put it into the sample. This is so-called sampling frame, okay? Without a clear identified sampling frame, then we have no idea to collect our sampling units at all. Is that right? Okay? So basically, however, in our social study, for a lot of studies, they are not able to provide a clear defined sampling frame. For example, a poll in Taiwan, the target population is 23 million people, right? But do those polling companies really have a sampling frame in their database, including 23 million people's contact information in their data bank? No, they don't have. So they could only approximate by using the telephone, by using the cell phone numbers, right? But still, it has some problem. Homeless people do not have cell phone. Younger generation do not have land-based telephone number. Is that right? So you can instantly identify this kind of sampling frame does have flaw. So the polling companies need to use multiple sources to cross-check to make sure that the sampling frame is as perfect as possible. Okay, it's very important. And the sampling statistic refers to the statistic we collect from the sample. It is called a sampling statistic. The sampling statistic is something we use to estimate the population parameters. Here is the population parameter. Or the population mean. 母群平均值. So basically, we are using sampling statistics, 样本统计数字, to estimate population parameters. So when we say parameters, it refers to a certain range, right? So even it's not a precise number, okay? And saturation point, we just said, to a degree, to the extent that no more significant data or information we can add in, then that is the saturation point. Okay, we have. And the principle of sampling here. which we have highlighted already. In a majority of cases of sampling, we know sample statistics is not equal to the true population mean. Do you agree, right? So the average height we collect from, we survey from the sample, 500 students, 158. Most of the time, it is not equal to the true population mean for Wenzhou student, 9,000, is 160, right? So it is not equal. So basically, how can we make sure that the estimation of the parameter, population parameter, is as precise, close as possible? Basically, there are some rules out there. The greater the sample size, if we have a larger sample size, then our prediction, our estimate will become more accurate. Our estimate will become more accurate, okay? The other consideration, if the variable under study is more different among themselves, more different in terms of their values in one variables, then the greater will be the difference between the sample statistic and the true population. Which means that if we collect data from the sample, and the variables within the samples have more values than the other sample, and then the estimation will be less accurate. So basically, the larger the sample size, the more accurate the estimate for the population parameter. The more varied of the variables inside the sample, the less accurate the estimation for the population parameters. So both two considerations are very important. What does that mean to the variation of the variable? Okay, let's talk about this. How about gender? The gender has only two values, male and female, right? Okay? And how about the different departments? Wow, that is more varied, right? We have about 12 values for the departments. We have a department of English, department of IA, right? So think about this. If you are only estimate the difference between male and female, your estimation for the true population mean will be much accurate than if you want to compare the difference between the departments. Is that right? Because departments are more varied in this way. There are 12 values under there. And here there are only 2. Okay, so we have to consider all the different characters out there. So there are only 2 considerations. The sample size, the variations of the sample variables. Okay? So in this regard, we have the so-called sampling error. Sampling error refers to the comparisons, the difference between the sample mean and the population mean. Let's look here. We have 2 sets. This is the real population average. And we have a sample 1, 2, 3, 4, 5, 6. And another we have a 1, 2, 3, 4, 5, 6 supposedly. Okay? Let's look here. This is the first sample. The average sample statistics is 19 to 24, right? And the difference between these two is negative 2.5 to positive 2.5. So we have differences. But basically, what we have for our study is really here. We can only identify the number of the average mean of the sample. And we can use this to estimate, basically we estimate the population mean, right? Okay, so you can see here, what we do is to collect data here, 19, so we estimate the parameters of the population, so right, okay? And there is a huge difference between this one, you see this one? We collect data and we estimate, and the real difference is negative 2.5 to 2.5. And let's see another sample. Our average is this, 20.33, right? And to 22.67. And we use the sample to estimate this. And we have a difference between mean and the population mean. Here, I want to ask you, if you look at the two differences revealed from the two tables, which table of the sample is smaller? Which samples are smaller? Do you mean the second one is smaller, has a smaller sample size?
It has this, yes, because it only has 4, whereas one has 6.
Oh, okay, how about this? Let's take away this. 4 to 4, okay. Which one is smaller? Has a smaller sample size? Which set of sample has a smaller size? Number 1, okay, Devon said indicate number 1. Yeah, it is number 1 because the smaller sample size has a larger difference between the estimation for the population mean, right? So you can see this is larger, and this is smaller, right? If this is smaller, it indicates the sample size of this group is much larger than this one. Larger than, so you can have a closer, smaller estimate of the differences. Okay? So this is called as sampling error. It happens, must be there. But the problem for us is to identify the differences. What is the range? Okay? And there are some factors can affect the inferences we draw from the sample. Here, look at here. Normally we collect data from here. This is the data we collect, so we have an average we identify from the data, right? So we use this to estimate this. Is that right? Estimate. So what other factors can influence this kind of precision estimation? How precise we have? So basically the size of the sample. The larger the better. Is that right? And the other one is the extent of variation in the sampling population. Variation. Just as I say, if we want to compare only the gender differences, but it will be much precise, right? But if we use the same sample size, try to estimate the difference among departments, then we have 12 variations out there. So that would be more difficult. Is that right? Okay. And let's give you some idea about the degree of freedom. Degree of freedom normally is denoted degree of freedom. What is the so-called degree of freedom? Let's talk about gender. Gender, we have 2 values, right? Okay. And the departments. Let's say we have 12 different departments. What is the degree of freedom for gender? Well, it is 1. Which means that if we put 1 under control, then there's only one can be free. So that is a so-called degree of freedom. A degree of freedom. And let's talk about departments. What is the degree of freedom for departments? Remember, we control 1. So there are 11 departments can freely running around, right? So the degree of freedom for department is 11. It is a very important idea for future statistical understanding. But for now, the larger the degree of freedom, the less accurate of your estimate for the population mean. Very simple. Okay? You get it? So far, if you know this, that will get enough. So degree of freedom is something for you to understand the distribution, the variation of the data. Okay. Next. So we try to select the sample, right? We want to show. Basically, we use the sample size. We use the sample statistics to estimate population parameters. So how can we assure our estimation is as accurate as possible? So that is our goal. We have to make sure that the selection is close as possible, right? So the answer for selecting a sample includes several considerations. We try to achieve maximum precision in your estimates within a given sample size. If you have the budget for selecting only 500, then you have to make sure that the selection of 500 is as close as possible. Is that right? So there's something. You try to avoid bias in the selection of your sample. You try to do. So if possible, you will avoid a non-random method. Listen to me, if possible. But in reality, I bet all of you will use non-random methods for selection. But for natural science, random selection is always there because they are mice, right? Mice can be randomly selected without harm, without any feeling. But a human being are a different story. So basically, we try to avoid, but in reality, we have to use it all the time. And the other one, sampling unit does not cover the sampling population. 9,000 students, basically the sampling unit should be there in the office or academic affair, right? I need to collect, but due to the law to protect the privacy, I have no way to access. So in this regard, I cannot have the sampling unit, sampling frame. If the sampling frame does not cover the the population I want to collect data, well, then that will have some trouble, right? And in accessibility of a section of the sampling population could cause your problem for sampling selection. Just as I said, homeless people, right? If they select the sample, if they select a sample with cell phone only, then you can see the old folks will have no chance to get selected, right? If they count on land-based telephone only, then you have no idea about what kind of survey it is, because you have no chance to be selected at all. So you have to think about all the possibilities. So this kind of inaccessibility issue is always there. Okay. So we have different types of selections out there. Basically, you need to look at here only. The first one is random. We can call probability sampling. The other one is non-random or non-probability sampling. And the combined one is called as mixed sampling, mixed together. And we can see here, under random sampling, we make sure that every sampling unit has equal chance of being selected. Okay, this is random. So based on this, we have a different strategy. One is a simple random sampling, or we can use stratified random sampling, or clustered sampling. The definition of these three, maybe they are somewhat different, but under the three different strategies, all the sampling units inside the population have the equal chance of being selected. Equal chances. Okay, later I will explain a little bit more. And non-random, which means you don't count on random selection. So what are they? Well, quota. For example, I have no way to do random, but I do need to have some sample for me to collect data, right? So if I want to understand the Department of International DIS students' idea to work something, so I give you 20 for the third year students, 20 questionnaire for the first, 20 for the. So each year I take back 20. So this is quota. I just take it for 20 back. It's fine, right? And I have to explain why I want to use this approach, of course, but workable. And judgmental, I determine it is good for you. For example, I would like to investigate how foreign students' idea toward our teaching in the department, right? So I judge you are foreign students, or I believe that you are capable of answering this one, so I give it to you. I found out you are very active in participation, I give it to you, right? If I found out you are always out there and not in the department, I believe that you have no idea about how the department is doing its business. So there's nothing for me to have information from you. So I decide not to give you a survey. Judgment. This is judgmental. And accidental, just as you said, accident, you just happened there, right? So never claim that you stand in the front gate of Wenzhou and expect the question, you say this is random. No, it's not random. Because at that specific time, many of the sampling units just do not go through that door. And they are still within the population. Is that right? So they have no chance to being selected. So that is not random. They call accidental. And snowball. Snowball is very easily to be understood, right? You give a bunch of questionnaires, let's say 100 copies, to one of your friends in another school. That friend separate this into two piles and give it to two other friends. And go on and rolling back. And you have a pile of strange respondents' answers out there. You have no idea who they are. So this is called as snowballs. Sometimes the interview, the survey done through the internet has some similar effect. It's like a shotgun. You just send it out, take it back. You have no idea about the characteristics of the respondents at all, or whether they are the real persons they claim they are. Is that right? So basically you have to describe all the scenario for the readers to judge the quality of your data collection. Okay? The other one is a mixed sampling. You can mix them together. And which one is better for you? The answer should rely on what kind of research questions you are doing. Whenever you have a research question, you look at that and you are going to start to look at for more details about the sampling strategy you need to have. You can use random, non-random, or mixed. When we talk about random, we have three different kinds: simple, stratified, and cluster. What is stratified? 分层抽样, which means that, for example, if I want to study students, DIA students' attitude toward professors' teaching advocacy, right? So ideally, I don't want to survey 200 or more than 200 students' attitudes, because of the budget. I'm a poor professor. So if I could only survey, let's say, 40 students, okay? So what would be the best strategy for me to randomly select the students from the department? If I use simple random strategy, what would happen? I put 220 students into the data and into a sampling frame, and I select randomly 40 students, maybe 30 students, 30 of them come out of first year student, 10 of them come out from the second year student. What about the third year, fourth year, and graduate students? I have no selection at all, although it is based on random selection, right? So it is not a good idea. Okay, in this case, maybe I can use stratified random strategy. That is, okay, I divide the 4 years of students into 4 different categories. So for the first year students, I will need to have 10 students. So I randomly select 10 students from first year, 10 students from second year, 10 and 10 from third and fourth year student, right? Okay, so basically I have 10 students from each year. but with a consideration of different weighting. For example, there are only 45 students from the 4th years, and I select 10, right? So each of the students carry a weight of 4.5. But for the first year, we have 62 students. So each student I select carry a weight of 6.2. But in this stratified random strategy, I can make sure that I have the sample unit from each of the year of the student, each year of the student. I can do analysis, right? So this is the basic idea, so-called stratified. We have a stratified sampling. We make sure that each stratum has some sampling unit included into the analysis strategy unit. So if you want to understand more, in next time you have the chances to do this kind of random sampling strategy, you can read more by yourself because it requires certain steps of doing it. But how about cluster sampling? Cluster sampling is often refers to if you want to collect data from the sample, but the sampling units are dispersed in the huge wide location. It will be very difficult for you to collect data from users, very simple. So you need to cluster. You focus on one cluster and select all sample from the cluster. And the idea here, let's move to here. This is a very good example of a cluster sampling. For example, you want to do some study about the quality of higher education in Australia. And in Australia, there are many different kinds there are 4 kinds of higher education institutions. Universities, University of Technology, College of Advanced Education and TAFE. They have 4 different kinds, right? Denoted by the different symbols here. Okay. So in this case, you still want to study, right? You want to identify the quality of the education, higher education. But look here, can you use random sampling in this case? Not quite. Not quite. Because you random sampling, you may be able to just select sample from here, 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 and here, right? If you are counting on random strategy, there will be 2 problems. The sample for each of the different type of university may not appear in your sample. The second consideration is the location of the different location of those schools are so wide. It was not possible for you to go there. You can get, this is Australia, not in the classroom, right? So you have to travel all the time. It's not possible. So random selection is not possible. Let's consider another possibility. We call stratified random strategy, right? Which means that, okay, we have 4 different kind of university. Okay, with stratified random strategy, we select 2 out of this. So we select 2 from this school system, 2, 2, 2, 2, or 3, 3, 3, 3. And still, the dispersion of the location is still exists up there, right? So you can see we select 2 here, and this and here. And we select test, and here, and here, and here. You can see the location is still so widespread. So the only way for us is to use cluster, random sampling. That is, we focus on one area, cluster. So we circle, we make sure that there are some circle clusters up there. So we base on cluster. This is cluster, okay? So the idea of clusters random sampling is that we randomly select 1 or 2 clusters. So if after selection, we have 2 clusters, okay? And then we go to investigate, collect data from all the higher education institutions inside the cluster. So basically, the researchers need to go here and here. Is that right? Only 2 locations. But still, there is a concept of weighting. We need to put in a weight to each of the institution we collect data. This will represent a different weight because we have to compare to the whole sampling units to see how much weight we need to carry, right? For example, if you, in the cluster, you select 5 colleges of advanced education here, then you have to consider if there are 35 colleges of advanced education, then 5 compared to 35, then the 7, the weight is 7 to each of the sampling unit. So this is cluster random sampling strategy. Of course, there are some detailed techniques you need to know, but this is the basic idea. So it seems that this is the only strategy we can count on, right? Okay. Any questions so far? If not, let's talk about this. Non-random or non-probability. We have this, different kinds. In social study, it's okay to use non-random sampling strategy, but it is not okay for you to disguise your ways of non-random strategy as random strategy. It is cheating. You have to explain why you use a specific non-random strategy. Because people would understand it's not possible for you to use random strategy all the time. So non-random strategy is used, but you have to explain. You have to give a very good reasons why you choose a certain way. Okay? So don't cheat. It's very important. It's quite natural. We will agree, but you have to explain. Okay? And here comes out the calculation of sample size. Basically, when we calculate sample size, we consider how confident we want to have, the level of confidence level. Confidence level, we say 95% of confidence level, right? It refers to 2 standard deviations, positive and negative 2 standard deviations. So here comes an issue. Let's move to the first slide, random, the normal distribution. Okay. This is a very simple one. We say this is 0 standard deviation line here, right? So here we only indicate the spread of the standard deviation here and here, standard deviation. So the number of the standard deviation can determine the spread of the distribution of the data. If the standard deviation is equal to 1 and another standard deviation is equal to 100, the distribution of the 2 sets of data are very, very different. You can see that, right? Very, very different. So the idea for us is to provide a narrower standard deviation so that we can assure the estimate of the parameters. So the sample size is very important. Sample size, the larger the better. The larger the better, okay? So if you understand this, that will be good enough. So this is just for your reference, and you will see that if you want to explore, you want to become a statistician, you may want to know this. But so far, it's okay not to do that, okay? And here comes the reminder. Next week, we are proceeding to writing a research proposal. Why do we need a proposal? As you, next semester, you will be preparing your GP proposal, right? And you need to learn some rationale for that. We have a quiz for today's lesson. And there's a research proposal number 9. Think carefully about from whom or what, which means your study population. You would like to collect your data. Study issue, study population. Study population are the target for you to collect data to answer your study issues. Okay, very simple. So you have to think about study population. They are not necessarily human beings, documents, maybe. Some sources of the data archive, maybe, right? You have to identify. Then elaborate that if you need to choose a sample from the population, if you are using qualitative research, definitely you need to have a sample from the population. If you are using qualitative research, you just go to the sample. You do not have a population sample. If yes, explain how. If not, why. Answer that, okay? And again, remember next week I will give you the survey form for your advisor selection. And now is a very good time for you to start think about this issue seriously and carefully. Okay, I will see you next time and have a good lunch. Bye.
Thank you.
You're welcome. By the way, before you go, turn off the computer and take away all the garbage you may find and take away. Thank you.
我想问一下，今天写的那个 research topic 就是到时候就要交上去了。
不，他一直在改变，没关系。
哦，好。
对，一直在改，对，不必担心。